So far we learned about the definition of eigenvalue and eigenvector. We have a theorem that basically gives us the eigenspace corresponding to eigenvalue lambda, which is the set of all eigenvectors that satisfy in this equation union along with the zero vector. Another theorem for you. This theorem says, suppose you have an n by n matrix. Let A be a square matrix. First of all, an eigenvalue of A is a scalar. Eigenvalue of A is a scalar. Like lambda, it gives us some shortcuts to find the eigenvectors, such that the determinant of lambda times I minus matrix A is 0. So to find eigenvalues, you only need to set up the determinant equal to 0 and solve. 2, another shortcut for you. The eigenvector of A corresponding to eigenvalue lambda are basically non-zero solutions. Are non-zero solutions of this equation, lambda I minus A times X equal to 0. Okay, give us an example. So let us take a look at this example together. The example says, find the eigenvalues and eigenvectors. Eigenvalues and eigenvectors of matrix A, which is given to you as 2, 1, negative 12, and negative 5. Very good. Let us begin. We're going to form the determinant of lambda I minus A and set it equal to 0. We are creating something that we call characteristic polynomial. Let me write it down. So you are finding the determinant of lambda times 1, 0, 0, 1 minus matrix A 2, 1, negative 12, negative 5, which is the determinant of, so here you have lambda 0, 0, lambda minus 2, 1, negative 12, and negative 5. Going slanted. The determinant of lambda 0, 0, lambda 2, negative 12, 1, and negative 5. Okay, let's combine these two and form the characteristic polynomial. So here you have lambda minus 2. Then you have 0 minus 12, which is 12. Then you have negative 1. Then you have lambda plus 5. So the determinant of this matrix is just multiplication of these two. Lambda minus 2 times lambda plus 5 minus, well, you have plus 12, right? This guy is called the characteristic polynomial. You need to set it equal to 0 and solve as you solve any other algebra problem. So we get lambda squared plus 5 lambda minus 2 lambda minus 10 plus 12 equal to 0. Or lambda squared plus 3 lambda plus 2 equal to 0. We're looking for two numbers, the product is 2, their sum is 3, so you have lambda plus 2 and lambda plus 1 equal to 0. We end up having 2 lambdas, am I right? Lambda can be negative 1 and lambda can be negative 2.